Today we're going to be talking about angle relationships. We're going to start off by going over some definitions, and then we're going to start finding missing angles using some algebra. So the first definition we're going to go over is adjacent angles. Adjacent angles are angles. I'm going to start with the basic definition. They're the angles that are directly next to each other. So that's like the first basic idea of what adjacent means, is that they have to be next to each other. So angles that are directly next to each other, but it's a little more in depth than that. Okay, not only do they have to be directly next to each other, they have to share a common ray and a vertex. Okay, but they cannot have any common interior points. So what do I mean by that? Basically what I mean is no overlapping. Okay, but I'll show you that right now with this picture, what I mean by that. In this scenario, it says angle ABC. So I'm going to trace that with my pencil. Angle ABC is this right here. And then angle CBD is this one right here. Just using a different pattern so you guys can see them. Obviously, you can tell that they're directly next to each other. They share ray BC. So BC is a ray. They share that side. They share the vertex B. And they have no shared interior points, which remember I said that means they don't overlap, right? They're directly next to each other, but they don't overlap. This example over here, we're saying is a bad example, so I'm going to show you this one. ABD is this whole big angle right here. Angle ABC is this little one right here, and you can tell right away that they absolutely overlap. All right, so I don't even have to worry about filling in this other stuff here. They're overlapping, and therefore they are not adjacent angles because remember, adjacent angles cannot overlap. They're directly next to each other, but no overlapping. Okay, so you'll hear me say in class, they're neighbors, right? They're next to each other, but they don't live directly on top of each other. They're in different houses. So you can think about that in terms of neighbors. Another definition that you need to be familiar with is complementary angles. And these are angles. So complementary angles are angles that add to 90 degrees. So two or more angles that add up to 90 degrees. So in this case, if I give you one of the angles, well, all you need to do to find the remaining angle is 90 minus 57. 90 minus 57 gives you 33. So the complementary angle to 57 degrees is 33 degrees. Using the same logic over here, if you know one of the angles and you're trying to find the other, 90 minus 42 gives you 48. So the complement is 48 degrees. I'm just going to draw this for this one just so you see it. Oftentimes I'll draw pictures. If I see the word complementary, I know I'm thinking about a right angle, right? I'll draw my little box to indicate that. If I know that one angle is 42 degrees and I'm trying to find the other angle, I'll say it's X. I'm just doing 90 minus part. So the whole minus part gives me the remaining part, which is the same math we did over here. If pictures help you, I totally encourage you to draw them. If they're not that helpful, then don't draw them. It's really what works for you. Unless the directions specify, you're on your own with what method you use. Okay, last definition we're going to go over today is supplementary angles, and these are angles that add to 180 degrees. So if I was given one angle is 157 degrees, all I need to do is subtract it from 180 to get the remaining angle. So 180 minus 157 gives me 23 degrees. So my missing angle here would be 23 degrees. I guess they already gave us, that's a degree symbol, not a zero, by the way. Be careful of that because they look very similar. Over here, same logic. Supplement means they add to 180, so 180 minus 82 gives me 98 degrees. Okay, so that's just the basic algebra that goes with finding missing angles when knowing the definition. Now you have a picture in front of you. It doesn't tell you how many degrees this is, but you know that a straight line has 180 degrees in it. So 180 minus 55 should give you the remaining angle, which obviously is obtuse, so you know it should be greater than 90 degrees. And when you do that subtraction, you get 125 degrees. Same logic here. If it helps you to turn your paper, that's always an option. So sometimes I actually will on my desk turn my paper, so I'm kind of looking at this straight on. If that helps you, great. If it doesn't, then don't change it. But again, you have a straight line. So I know that I'm doing 180 degrees minus 137 degrees. And when I do 180 minus 137, I get 43. So A is 43 degrees. Over here, Z was 125 degrees. And notice in this problem, we have 3 unknowns, and I know that because I see 3 variables. Okay, well, what's great is that I don't see any right angles, but I see a lot of straight lines. So for example, you could really start anywhere in this problem. I'm going to start here. I know that this angle and this angle together form a straight line. So on my paper, 180 minus 125 should tell me what M is. So if I do 180 minus 125, I get 55 degrees. So M is 55 degrees. That same logic, I'm going to erase my line just so you can see it, but you can always leave yours on your paper if you don't need to erase it. I see a straight line over here. That same logic is true that a straight line has 180 degrees in it. So again, I know 180 minus 125 will also give me N. And I've already done that math, so I know N has to be 55 degrees. To get P, I can either use M or use N. I'm going to use N because I know that these form a straight line together. So if I do 180 minus 55, I know that has to give me P, which is 125 degrees. Notice, we're gonna talk about this later in this unit, but notice that 125 degrees, 125 degrees, 55 degrees, 55 degrees. And notice that this is formed in X. That's going to be a definition we get to soon. All right, in the next picture, I have 2 missing angles, and I know that because I see 2 variables, and I'm just going to choose to work with X first because it's the first one I noticed. Notice that you have a right angle here because of the box. That's an indication. This angle and this angle together form 90 degrees. So in order to find X, if I do 90 minus 78, I'll find the missing angle of 12. Over here, I see that Y is directly next to 157 degrees. They are adjacent angles. I could have said that as well about X and 78. That is true about them as well. They're adjacent angles. So anyway, sorry. They form a straight line. So if I do 180 minus 157, I will get my missing angle. That would be 23 degrees. So now I have X and I have Y. For X, I could only use 78 because they were adjacent to each other. For Y, I could only use the 157 because that's what's adjacent to it. All right, I love these problems. I love these types of problems that we're about to do, and here's why. I really like when different areas of math connect, and in this case, we're going to see that algebra connects to geometry, which I think is a really cool thing. In this picture, hopefully you notice straight away the right angle. That tells you this is a 90-degree angle. It also tells you that these angles are complementary angles because remember your definition of complementary angles are angles that add up to equal 90 degrees. So I can write a basic definition to help me find the missing angles. If I take angle A and I add it to angle 2A minus 6, together I know they have to add up to 90 degrees. Remember that whenever a variable is by itself, it has a coefficient of 1. I'm going to put a line through my equal sign just to help me with my math procedures here. I'm going to combine like terms. 1A and 2A I know is 3A. I'm going to bring everything else down. Add 6 to each side, so I'm left with 3A is equal to 96. Divide each side by 3. A is equal to 32. I'm going to put a degree symbol there, circle my answer, go back up to my picture, always write my answer in my picture, And I'm still left to find this missing angle. So what we're going to do now is take this expression, take our value, and substitute it in. So I'm going to do 2 times 32 minus 6, 2 times 32 being 64, 64 minus 6 being 58 degrees. Once I've done that, I'm going to do a quick check on the side of my paper. At the very least, please do this on your calculators to verify that it makes sense. My 2 angles together, we said we're supposed to add up to 90 degrees, right? That was the definition of complementary angles. So over here, if I do 32 plus 58, hopefully I get 90, and I'm going to type this into my calculator just to be sure. 32 plus 58, it does give me 90. So 90 equals 90. My math works. Again, if you don't put this on your paper, at the very least, type this into your calculator and verify you get the number you wanted it to be. All right, last one of the lesson. Notice we no longer have a right angle anymore. We have a straight line. Hopefully, if you think about a straight line, you're saying to yourself, there's 180 degrees in this straight line. These 2 angles together are called supplementary angles because they add up to 180 degrees. Okay, so I'm going to write an equation. 2x minus 19 plus my other angle of 3x plus 4 has to add to 180 degrees. Put a line through the equal sign, start combining like terms. 2x and 3x gives me 5x, so I'm going to cross those out. Negative 19 and positive 4 gives me minus 15 equals 180. Going to add 15 to both sides of my equation. 5x is equal to 195. Divide each side by 5. When I divide 195 by 5, I get 39 degrees. However, neither of those are just x, so that's going to require substitution for both. So 2 times 39 minus 19. Using order of operations, the first thing I'm going to do is 2 times 39, which is 78. Subtract 19 from it, and I get 59 degrees. This number should make sense to you because we have an acute angle, and we know an acute angle has to be less than 90, and the number I got was less than 90. Going to do the same thing over here, substituting in for x, 39. So I'm going to do 3 times 39, which gives me 117. Have to add 4 to it, which gives me 121. Again, this angle is an obtuse angle, meaning it has to be greater than 90. My number is greater than 90, so hopefully that makes sense. My quick check, just like up above, I want to verify that my 2 angles together give me the straight line, which is 180 degrees. So 59 plus 121 does in fact equal 180, so I know that my math makes sense.